Hi students, today we are going to solve question number 4 from the exercise 10.1 of the chapter Straight Lines from the first PU syllabus. All the sums and derivations related to this chapter, you can find it in the playlist. Go to playlist and look for straight lines. You will be able to find the sums. Let us check the question number 4 and the question goes like this. Find a point on x-axis which is equidistant from the points 7, 6 and 3, 4. We have been given 2 points 7, 6 and 3, 4. We have to find a point such that that point is equidistant from these 2 points, and also there is a condition that that point should lie on x-axis. So we have to find a point on x-axis which is equidistant from these 2 points. Okay, let us do it now. Let us call these points as A and B. Let A be 7, 6 and point B be 3, 4. Now we are considering the rectangular coordinate system and we are marking the points A and B. And also we are considering a point on x-axis which is equidistant from both of these A and B. So this is the point P. We all know that any point on x-axis will have y coordinate as 0. Because the point is on x-axis. On x-axis, y coordinate will be 0. So while considering the point, you have to carefully write the point as P of x, 0. So assume P of x, 0 be a point on x-axis that is equidistant from these 2 points. We considered a point on x-axis which is equidistant from these 2 points. So this is the point x, 0. Now when we have to find the distance, we already know a formula for it, that is distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now this part we have considered, that is x, 0 is the point we have taken. Now the condition given, that is distance between A and P, that is this distance A and P is same as this distance. That is the condition we are using now. Distance between A and P is equal to distance between B and P, which will be AP is equal to BP. Now we will apply the formula for these 2 points. First, AP. When you apply the distance formula, there is no hard and fast rule that you have to take this particular point as x1, y1 and the other one as x2, y2. Nothing like that. You can consider any point as x1, y1 and any point as x2, y2. So, similarly for this too. So we are applying the formula, distance formula for these 2 points again. So LHS would be, look at this, 7 minus 6 whole square, whole thing under the root, here also under the root. 7 minus 6 whole square plus 6 minus 0 whole square equal to square root of again 3 minus 6, this point, 3 minus 6 whole square plus 4 minus 0 whole square. Now on squaring, we can get rid of this square root, which gives us 7 minus 6 whole square plus 6 square equal to 3 minus 6 whole square plus 4 square. Now we have to expand these 2 terms as a minus b whole square, which will give us 49 plus x square minus 14x plus 36. That is equal to 9 plus x square minus 6x plus 16. Now you can cancel this x square and this numerical values can be simplified. Okay. After simplification, what we have got is 85 minus 14x is equal to 25 minus 6x. So I will move this 6x to LHS and 85 to the RHS so that we can simplify. It will be minus 14x plus 6x equal to 25 minus 85. So this is minus 8x is equal to minus 60. X will be equal to 60 by 8. So x is equal to 15 by 2. So this is the point. How do we represent any point on the coordinate system? It is like this. Thus, the required point on x-axis is P of 15 by 2, 0. This is a very simple sum. What you have to be careful is how to write the point. You have to cautiously write the point as x, 0. And the second thing that you have to consider is the condition given. That is, this point is equidistant from those 2 given points. That's all. So, this is a very easy sum. Hope it's very clear.